Hello everyone, I am Shubham Goekar and I will be presenting on a fundamental yet critical topic in machine learning, which is data preprocessing. So why do we even need data preprocessing? The simpler answer is that real world data is messy. It's often incomplete, inconsistent, noisy, and full of irrelevant information. In machine learning, the principle of garbage in and garbage out applies perfectly. If we feed raw, unclean data directly into our model, we will get inaccurate and unreliable results. Data preprocessing acts as an essential bridge, transforming this raw data into a clean, structured format that our algorithm can actually learn from. It is a non-negotiable step for improving accuracy, efficiency, and a model's ability to make trustworthy predictions on new data. This is critical everywhere from healthcare diagnostic to financial fraud detection. For example, imagine a customer dataset with missing age values and salaries is different in different currencies. Any analysis without cleaning this data first would be fundamentally flawed. Concept description. So now, what exactly is data preprocessing? It's a crucial step in machine learning pipeline where we prepare and clean raw data before building a model. It involves techniques to handling missing data, convert categorical text into numbers, scale features and reduce dimensionality. The main goal is to improve data quality to help us exact meaningful pattern for better model performance. We commonly do this using Python libraries like Pandas, NumPy, and scikit-learn. The key step involved are data cleaning, handling missing values, and removing noise. Second one is data integration, which is combining data from different sources. Third one is data transformation, which includes normalization and scaling techniques. And fourth one is data reduction. Selecting important features and reducing dimensions is very important. So it is one of the data reduction techniques. Now working. So how does it work in practice? We apply a sequence of operations. First, we handle missing values. We can either remove rows with missing data or input them using mean, median, or mode or more advanced model. Next, we encode categorical data. For instance, label encoding assigns integer labels like dog is equal to 1, cat is equal to 2. One-hot encoding creates separate binary columns for each category. Then we perform feature scaling. Algorithms are sensitive to uh, uh, scale of data standardization scales features to have a zero mean and unit variance, while normalization values into a range typically between 0 and 1. Finally, we might use reduction techniques like PCA, which is principal component analysis, to reduce the number of features while keeping the most important information. A simple code example for scaling using scikit-learn's standard scalar would look like this. From sklearn pre-processing, import standard scalar. Scalar is equal to standard scalar. X underscore scaled is equal to scalar dot fit underscore transform X. So this code uh, exactly tells about how standardized values are standardized using Python libraries. So the challenges and limitations. However, data preprocessing isn't a magic, but it has its own limitation. There is a risk of information loss if we are too aggressive with dimensionality reduction or imputation. Some techniques have high computational cost on very large dataset. There is also a risk of overfitting during imputation. If we use complex model to fill missing values, as it might accidentally learn patterns that doesn't generalize. Finally, many methods make assumptions about the data's distribution, which may not always be true. For example, using the mean values to fill missing salaries will underestimate the true variance of the data, leading to biased model prediction. Now, overall summary of this topic. So, in the summary, the key takeaways are: data preprocessing is a non-negotiable foundation for building robust and accurate machine learning model. It ensures model compatibility by converting data into numerical scaled format that algorithm expect. It enables better generalization by reducing noise, helping models perform well on unseen real-world data. Its impact in critical across domains, ensuring consistent patient records in healthcare, cleaning transaction data for fraud detection in finance, and preparing text data in NLP. Just think, model using features like income ranging in the tens of thousands and age ranging to 16 will be unfairly biased towards the income future without scaling. Pre-processing fixes this bias. So thank you. This is about uh, the data pre-processing. Thank you.